Hello and welcome to SAS video tutorial. Reading raw data files. Introduction to raw data files. So our objective here is to identify the types of raw data files and input styles. We will define the term standard and non-standard data. The business scenario here we have is information about Orenstar sales employees from Australia and United States is stored in a raw data file. Programmers need to be able to identify the layout Programmers need to be able to identify the layout and types of information in the raw data file. Again, we have the same scenario. We used this scenario in previous chapters. Raw data file. What is a raw data file? So a raw data file is also known as a flat file. They are the text files that contain one record per line. A record typically contains multiple fields. Flat files do not have internal metadata. External documentation known as record layout should exist. A record layout describes the fields and locations within each record. Raw data files. Fields in a raw data file can be delimited or arranged in fixed column. This is what a raw data file looks like. Notice there is no column heading. However, since we know this is sales employee data and we have been working with this type of data, we can figure out what the values are. Typically, if we have a raw data file to read in, we will need to be supplied the layout. Also notice the values are separated by commas. If we want to go out of SAS and open the file from Windows Explorer in Notepad, we are using Windows and Unix naming convention for the raw data file throughout this slide. Fields in raw data file. In order for SAS to read a raw data file, you must specify the following information about each field: the location of the data value in the record, the name of the SAS variable in which to store the data, the type of SAS variable. Reading raw data files. There are different techniques or input styles for reading raw data file in SAS. Input style: column input, formatted input, and listen. Column input: standard data in fixed column. Formatted input: standard and non-standard data in fixed column. List input: standard and non-standard data separated by blank or some other delimiter. Standard and non-standard data. Standard data is the data that SAS can read without any additional instruction. Character data is always standard. Some numeric values are standard and some are not. Now let's talk about the difference between standard and non-standard data. List input or format input must be used to read non-standard numeric data. Standard numeric data, where the number could be either positive, negative, in decimal, in exponential format, either positive or negative. Reading standard delimited data. Our objectives are: use list input to create SAS dataset from a delimited raw data file, examine the compilation and execution phase of the data step when reading a raw data file, explicitly define the length of a variable, examine behavior when a data error is encountered. Business scenario. Information about Orenstar sales employees is stored in a comma delimited raw data file. The file contains both standard and numeric data fields. List input. For our scenario, we are going to use list input because our file is delimited. This is the partial view of the sales.csv raw data file, which is separated by comma. SAS considers a space blank to be the default delimiter. Both standard and non-standard data can be read. Fields must be read sequentially left to right. Reading a delimited raw data file. We are going to use infile and input statements in a data step to read a raw data file. Infile statement. The infile statement identifies the raw data file to be read. The syntax is infile, then the raw data file name, and if any delimiter is there, then we use dlm equal to option, and then we specify the delimiter within single quotes. The full path is recommended. Using the %path macro variable reference makes the program more flexible. The dlm equal to option specifies alternate delimiters. Be sure to use double quotation mark when referencing a macro variable within a quoted string. A %let statement was submitted as a part of libname.sas to create the user-defined macro variable path. The infile statement references the macro variable by placing an ampersand before its name. The macro variable will exist for the duration of the SAS session unless it is changed or deleted. Input statement. Remember, the fields must be read in the order in which they appear in the delimited file, and you cannot skip over fields. You do not have to read them all, but you must read up to the last one you need. The optional $sign indicates a character variable. Default length of all variable is 8 bytes regardless of type. Let's submit this program. This output looks pretty good except for the job title. The values are getting truncated. In fact, first name and last name are also getting truncated. Let's view the log. The log contains information about the input file and the new dataset. 165 records were read and 165 observations were created. The new dataset has 7 variables because we supplied input specifications for 7 fields. Behind the scene, the data step processing is somewhat different when we are reading from a raw data file instead of a SAS data step. During compilation, SAS checks the syntax of the data step statements, translates each statement into machine language. It creates an input buffer to hold a record from the raw data file. This is the additional step. Creates a program data vector to hold the current observation, and then it creates the descriptive portion for the new dataset. During the compilation phase, each statement is scanned for syntax error. Most syntax errors prevent further processing of data step. After that, SAS converts the program into machine language. Then the input buffer, an area of memory, is created to hold a record from the external file. The input buffer is created only when the raw data is read, not when a SAS dataset is read. The term input buffer refers to a logical concept. It is not a physical storage area. The default length of the input buffer depends on the operating system. It can be modified using lrecl equal to option in the infile statement. After input buffer is created, program data vector is created. The program data vector is the area of memory where SAS builds a dataset, one observation at a time. Like the term input buffer, the term program data vector refers to a logical concept. With list input, the default length of the character variable is 8 bytes. As the input statement is compiled, a slot is added to the program data vector for each variable in the new data set. Usually, variable attributes such as length and type are determined the first time a variable is encountered. Any variable that are created with an assignment statement in the data step are also added to the program data vector. At the bottom of the data step, when the run statement is encountered, the compilation phase is complete and the descriptive portion of the new SAS dataset is created. The descriptive portion of the dataset includes the name of the dataset, the number of observation and variables, the names and attributes of the variable. Data step processing. If the data step compiles successfully, then the execution phase begins. During the execution phase, the data step reads the observation from the raw data file set and creates observation in the data portion of the output dataset. By default, the data step executes once for each record in the raw data file. Moving on to the execution phase, SAS initializes the program data vector to missing, and when it goes to infile, then it reads infile statement. After that, SAS reads a record into the input buffer. SAS reads from non-delimiter to delimiter and assign the data value to the corresponding variable in the program data vector. The value is converted from the text to a floating point numeric value and copied to the PDV. It skips over the delimiter and begins at the next non-delimiter, again reading until it hits a delimiter. The text value is copied to the PDV without conversion. SAS continues reading from non-delimiter to delimiter, writing values to the next variable in the input statement until all the variables have been assigned values. Then it writes an observation to the new dataset using the data in the program data vector. At this point in the execution, this is what we have in the output dataset. Then it writes an observation to the new dataset using the data in the program data vector. When SAS returns to the top of the data step, the PDV is reinitialized. When reading from a raw data file, the entire PDV is reinitialized. Remember, variables from the SAS dataset are not reinitialized. But in this case, no variable are coming from a dataset. They are all new variables and therefore all are reinitialized. The infile statement is read again. SAS reads a record from the raw data file each time the input statement execute. This is the second iteration of the data step and it reads the second record from the sales.csv file. Once again, SAS reads from non-delimiter to delimiter, assigning data values to the variable named in the input statement. At the bottom of the data step, SAS writes the second observation to the new data set. SAS continues looping through the data step until SAS reaches the end of the file on the raw data file. Here is the output that we saw earlier. Let's address the character truncation issue. Remember that with the list input, all variables are 8 bytes long. Regardless of the type, 8 is really the ideal length for a character variable. In this example, it is too short for the first name, last name, and job title, and longer than necessary for gender and country. We need to set the length for the character variables. The length statement can be used to predefine the length of each character variable. Notice that we are specifying not only the name and length but also a type of each variable being defined. SAS uses this statement at compile time to create the slot in the program data vector. The variables in the length statement are created first in the order they are listed. Then SAS scans the input statement to see if any other variable are listed. If finds employee and It finds employee ID and salary and creates slots for them in the PDV. Notice that first name and job title are no longer truncated, and that the order of the variable is different from the original. It is based on the order of the variables in the PDV. The type can be omitted from the input statement since the character variable have been predefined as such. However, you may prefer to leave it on so that it is obvious what type each variable is just by looking at the input statement. However, you may prefer to leave it on so that it is obvious what type each variable is just by looking at the input statement. Then we will display the variable that were created, and we will view those by the procedure contents. We will be using varnum option to retain the actual positioning of the variables in the dataset. And then we see the partial proc output of the program. Business scenario. A raw data file contains information about Orange Star sales employees. It includes some invalid data type. Let's look at the first part of our scenario, reading a raw data file and knowing that some of the variables need to be character and some needs to be numeric. Reading a raw data file with the data error. Here is the complete program. Notice that salary is a numeric variable and country is a character. When we view the output, a missing value was stored in salary for the input value NA. The value 12 was successfully stored in country. A data error occurred on observation 4 but not on observation 6. When we view the log, the data error occurs when the data value does not match the field specification. Data error. When we use data in file input statement, we are likely to encounter data errors. Data errors. When this kind of data error occurs, the following information is written to the SAS log. A note describing the error, a column ruler, the input record, the contents of the PDV. Data error. Two temporary variables are created during the processing of every data step. Underscore and underscore is the data step iteration counter. Underscore error underscore indicates error data status, where 0 indicates that no data error occurred on that record, and 1 indicates that one or more data errors occurred in that record.